In a courageous proclamation, researchers have announced the discovery of a celestial object unlike any previously identified. NASA, celebrated for its trailblazing insights, has disclosed that this planet is intriguing, not only because of its size and position, but also due to its emission of light that appears to be artificial. Could we be on the brink of uncovering hidden truths that might deeply alter our comprehension of the cosmos? This revelation imply the possible presence of life on other worlds? Examining NASA's groundbreaking findings, we will soon unveil the truths behind this extraordinary event. 2007, NASA launched the Dawn mission with the goal of studying some of the most fascinating objects within our solar system. Equipped with 3-ion propulsion engines, Dawn commenced its journey, beginning with a 14-month investigation of Vesta, the second largest asteroid in the belt. Dawn sent back exceptionally detailed images and data, shedding light on Vesta's complex surface and varied geological history. Upon completing its mission at Vesta, Dawn progressed to the next phase of its journey, one that was likely even more exhilarating, a comprehensive study of the dwarf planet Ceres. Thanks to its ion propulsion systems, Dawn was able to escape Vesta's orbit and head toward Ceres, a feat that would have been impossible with conventional chemical propulsion methods. These propulsion systems provided consistent thrust, allowing Dawn to cover vast distances and establish a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Pazzi, Ceres is the largest object in the asteroid belt, situated between Mars and Jupiter. For 4 years, it was classified as the smallest dwarf planet in our solar system until its reclassification in 2006. The diameter of approximately 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt, one of the most captivating due to its unique characteristics. Scientists eagerly awaited the first close-up images of this enigmatic planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known as a crater. These luminous spots ignited immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be composed of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts water or brine instead of molten. But what exactly are these enigmatic lights? And what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant milestone as it prepared to offer the first detailed views of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial photographs showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious, bright spots amid the dark, rugged terrain. As the image resolution improved, scientists began to formulate theories about the nature of these spots. Were they areas of ice reflecting sunlight? Or could they be something even more remarkable? Speculation ranged from mineral deposits to possible signs of cryogenic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had or possibly still has some form of geological activity capable of pushing water or brine to the surface where it rapidly evaporates, leaving behind bright reflective residues. The findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our understanding of the possibility of life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water, ice, and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. The composition suggests that Ceres may harbor significant amounts of water beneath its surface. Its outer layer is rocky but porous with trapped ice and other volatiles, making it resemble a comet more than a typical asteroid. It is believed that Ceres has a unique internal structure consisting of a rocky mantle and a core rich in water ice, which makes up about half of the planet's total volume. Her mantle is likely a mixture of rock and brine, surrounding a denser core possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres may have once supported liquid water, especially if its core was heated by radioactive decay during its early history. The internal composition sets Ceres apart from its neighboring asteroids and opens up fascinating questions regarding its potential for geological activity and the role of water in shaping its development. But that's not the entirety of the story. The detection of ammonia-rich clays on Ceres implies that this dwarf planet might have formed in the frigid outer sectors of the solar system before drifting inward. The presence of ammonia can decrease the freezing point of water, allowing salty liquids to exist either on or near the surface. These revelations regarding Ceres' composition and past not only broaden our comprehension of this captivating dwarf world, but also provide essential insights into the mechanisms that govern the creation and evolution of icy celestial objects across the solar system. Cryovolcanism is a remarkable and relatively rare geological phenomenon, especially when contrasted with the more common volcanic activity on Earth. Instead of discharging molten rock, cryovolcanoes or icy volcanoes emit substances such as water, ammonia, or methane. These materials can stay in liquid or gaseous states even in extremely cold surroundings. On Ceres, cryogenic events allow salty water to rise to the surface. When this briny liquid reaches the vacuum of space, quickly undergoes sublimation, shifting directly from a solid or liquid into it. What is left behind are shiny salt residues that appear as the strange, bright marks visible on the planet. The most prominent of these reflective areas is located within a crater, specifically in a section informally referred to as Spot 5. This location has attracted significant scientific attention due to its high reflectivity and documented changes over time. These changes are thought to be connected to the sublimation of water, implying that cryovolcanism may still be occurring or happened not long ago. In addition to Spot 5, Ceres features many other glowing areas, each with its own distinctive characteristics. The spots aren't limited to one location, but are scattered across the planet's surface, suggesting that cryovolcanic activity might be widespread. Their presence reinforces the idea that Ceres is geologically active and disproves older theories that portrayed it as a dormant, lifeless object. As the Dawn mission kept sending back increasingly precise imagery, it revealed a terrain covered with impact craters, each telling part of Ceres' ancient narrative. From the scientific community, interpretations of this new world developments have significantly altered our perspective of Ceres, with its icy composition and indicators of potential cryovolcanic phenomena. The planet now appears to be an active evolving world, no longer just a frozen remnant of the early solar system. The shining spots, especially those within a crater, continue to captivate scientists. They may not only signify geological processes but could also point to conditions capable of sustaining subsurface liquid water. Investigating Ceres offers broader implications than simply learning about one dwarf planet. By studying its interior structure, surface irregularities, and reflective deposits, experts can gather knowledge applicable to other icy celestial entities in our solar system. The elements found on Ceres, such as water, ice, ammonia-infused clays, and bright salts, can reveal much about the chemical makeup and environmental dynamics of similar planetary formations. Furthermore, the possibility of cryovolcanism opens new and exciting pathways to explore geological activity, not only on small planets and icy moons, but potentially on distant exoplanets as well. This line of inquiry suggests that zones we once assumed were static and uninhabitable might in fact sustain complex natural systems. Could this also mean that remote planets once dismissed as cold and lifeless may actually contain the essential conditions for life? Final thoughts on NASA's Dawn Endeavor, a legacy for humanity. NASA's Dawn program stands as a beacon of what is achievable through interplanetary exploration. The data it collected has already revolutionized scientific views on the genesis and transformation of our solar region. As we delve deeper into the mysteries of Ceres and other distant cosmic bodies, every piece of information helps us piece together the broader puzzle of how planets, moons, and other astronomical formations develop. At present, the glowing areas on Ceres are among the most perplexing mysteries in planetary science. That are only the beginning. With ongoing advancements in technology and the launch of future exploratory missions, the potential for even more astonishing discoveries grows. Once regarded as a minor and insignificant object in the asteroid belt, Ceres has emerged as a symbol of cosmic wonder and scientific promise. Its layered terrain, intricate internal composition, and puzzling luminous features may one day provide critical insights into our solar system's early years and the processes that led to the formation of planets. The possibility that Ceres could harbor microbial life, or at least the essential components required for life, remains an electrifying prospect that continues to inspire scientists and space enthusiasts alike. As we press forward into the depths of space, the line between what was once science fiction and today's scientific inquiry grows ever thinner. Could microscopic Organisms survive in the hidden liquid. Reservoirs of series? Environmental conditions on other icy celestial bodies support life as we know. Or life in an entirely unfamiliar form? These are the questions that will fuel the next generation of space research and perhaps one day uncover the fundamental truths of the cosmos.